Hello student, welcome to our web optics course. So today we have lecture number 22 where we going to study the Newton's ring that we already introduced in the last class. So today we will going to study how one can find out the condition for maxima minima of these rings. So today we have lecture number 22. So today our topic was Newton's ring. Well, in the last class we have already discussed how the Newton's rings are formed, the formation of the Newton's ring and the corresponding experimental setup. So today we will go to extend this idea to find out that what should be the path difference and what is the condition for getting maxima and minima in terms of those rings. So let me draw once again the geometry. So this was the slab, and over that we have a wedge like structure like this. And so this is R, the radius of curvature of this curve, and if I join that, then suppose the light is falling here and then get reflected from the lower surface and get interfered, and we have the interference. So this is ray 1 and this is ray 2. These two will going to be interfere. Now this length, this path difference, I write as T of m, and if this is origin from here to here, this point is say Rm. So the point is to find out Rm, this radius, because that radius is essentially the radius of the rings that we are going to form in terms of this path difference with the geometry that we have here. So let us try to do that. Let this is R and this is Tm. So if I put O here and this point is say A and this point that is touching here is B and this point is D. So my OD is equal to R, my that is equal to OB, but OB is equal to OA plus AB. My OA then is equal to OB minus AB. From this picture, it is easy to show that OB is nothing but R and AB is nothing but Tm. So OA, this quantity is simply R minus Tm. Now from this simple geometry we can write that R square is equal to R minus Tm square minus R in AD square. So, AD is equal to Rm, and I am just using the Pythagoras theorem, and which is AD square plus BOB square is equal to OD square, where my AD is Rm, OB is no, this is AO square, AD square plus AO square, and I make a mistake. Here we have AD square plus AO square. This is AO square. So, AO square is equal to R minus Tm whole square plus Rm square. Okay. Now, usually this R, radius of this curvature of this curve, is very greater than this quantity Tm. So, we can neglect few terms related to Tm square. So, in that case we have R square is equal to R square minus 2 of R of Tm, and I am neglecting the Tm square because Tm is very small compared to R, then it is simply plus Rm square. So, R square will cancel out, and I simply have Rm as root over of 2 of R of Tm. So, if I want to find out what is the path difference at the point Tm, then path difference will be, for normal incidence, in this case all are normal incidence, the path difference at the point Rm, that is this point according to our figure, that is delta is equal to 2n Tm, where n is the refractive index of this region. If it is pure air, then it is simply 1. So, that we know, Rm we know, and this is the path difference we know. Now, as I mentioned that this point the two rays will going to interfere. So, let me draw here how these two waves are going to interfere. So, this is the structure. We have this wedge like thing, this is the slab we had, and the ray will fall here first and goes here, and another ray will reflect it from here. So, these two rays essentially interfere, 1 and 2, and this path difference, this distance is Tm, and that is the structure. So, ray 1 and 2 will interfere. So, the total phase difference then, because there is a reflection from this surface, if it is n and if it is Ng, so Ng is greater than n, so there is a reflection from this surface. So, total phase difference total phase difference will be k naught delta plus pi due to this reflection, and that is 2 pi by lambda. Path difference is 2 n Tm plus pi. Now, for maxima, if this interference generate a maxima there, that is a circle with maximum intensity, for maxima what we have? We have 4 pi divided by lambda, then n Tm plus pi, that is equal to 2 of m of pi, integer 2 pi, integer multiple of 2 pi, or 4 n into Tm divided by lambda, this first term is equal to 2 m minus 1, pi will cancel out, or in other word it is so Tm is 2 m minus 1 multiplied by lambda divided by 4n. So, that is the condition we have for maxima. For minima, similarly we can have the condition. So, from this knowledge, let us check that how one can use this Newton's ring to to form the to find the wavelength of the light that is falling over here. So, how you do the wavelength measurement, that I like to show here. So, that is the expression we have, that that this Tm where we have the maxima is this. Now, for dark ring, in the similar way I am not going to do this problem, because that is the okay. So, for dark ring, what happened, that this condition, the path difference which will be the phase for maxima, the phase difference which is 2 m pi, it will be just the integer multiple of for destructive condition, it is just 2 m minus 1 2 m minus 1 into pi by 2. So, from that you can find out the minimum. I am not going to do that, it is some sort of exercise that you please do. So, next thing that I do is this, that how to measure measure the wavelength Okay. So, so this is the structure. This two ray will interfere and form a bright ring or dark ring. So, we already had we already had the expression that if this is my Rn, that is the radius of, suppose it is forming a dark ring, then this dark ring radius is Rn, and Rn is equal to root over of 2r and this thickness Tm. Now if I multiply this with 2, then it is 2 Rn is equal to 2 of root over of 2r Tm, where this is my Tm, path difference. So, for air, if this is N, we know the path difference is 2 into N into Tm for these two widths. Now, for air, N is equal to 1 and the path difference delta will be equal to, this path difference delta will be simply equal to 2 of Tm. Now, for dark ring, we are talking about the dark ring because it is easier to calculate, that this path difference plus this change of phase which leads to another path difference delta r, this is the total path difference. If it is lambda by 2 integer multiple of, then we have destructive interference, dark rings. So, delta r is a path difference due to the phase difference of pi. Now, this condition, there is a, it is the multiple of lambda by, so let me erase this. Let me first find out what is the path difference of delta r. So, delta r is a path difference due to the pi phase difference between this pi phase difference due to pi phase difference of reflection. So, delta R is equal to lambda by 2. So, for distractive we have a condition like this, that it has to be the odd multiple of lambda by 2. So then delta, the path difference for it is for minima, then the delta will be simply 2m plus 1 lambda by 2 minus delta r, which is equal to 2m multiplied by lambda by 2 or m of lambda. That is the path difference we have for distractive interference. So, delta here I already calculate, it is 2 Tm, and that is equal to m of lambda. So, if I put it back here, this Tm 2 Tm value, then this will be 2 of root over of r multiplied by m lambda, and that is again the diameter of the dark ring. Dm is the diameter of the dark ring. So, dm is 2 root over of r m lambda, that we figure out. Now, if I write it here, that suppose we have a dark ring, say this is my dark ring that we find, and this is the mth order dark ring, this is the mth order dark ring, and whose diameter dm is, as I calculate, let me see what was the calculation, dm is 2 root over of r m lambda. So, 2 root over of r m and this wavelength lambda, where r is the radius of curvature of this curved surface that we had to find the Newton's ring. This is mth order. There are other rings also, because this is a concentric, this structure is the concentric structure. Suppose these are the different rings, and I am just talking about this mth dark ring. This is mth, suppose this is the mth dark ring. So, I can have dm square here as 4 of r m lambda. So, I can measure the mth order dark ring, and if dm is measured, then I can find out that this value will be 4 r m lambda square. Similarly, I can also measure some other order, suppose dm plus pth order dark ring, and for that this value will be 4 into r multiplied by m plus p lambda. If I subtract this dm plus p, this we can measure experimentally, this left hand side, and then we play with the numbers. Then we have 4 p lambda r. So, lambda, then one can find out easily with the expression that dm plus p plus minus dm square whole divided by 4 of p into r. Now, by measuring, so we measure experimentally, what we measure? Experimentally dm and dm plus p can be measured. So, experimentally through experiment we can measure dm plus p and dm, where the value of the p is also known. I know that which order I am measuring, and then exploiting this expression by knowing the value of r. So, r, if somebody provide it, then all the right hand side is known. So, I am doing an experiment without knowing what is the lambda, then I Newton's ring experiment. So, in Newton's ring experiment, this is the structure. So, light is falling here like this. The experimental setup I mentioned also in the last class, that how, so light will come from here, reflect and make a ring like structure like this, and then by using the microscope we can find out what is the value of the diameter of these rings, and with knowing all this value in the right hand side with the value of r, I can find out what is the value of lambda. So, this is one very important experiment, and through which you can measure the value of the unknown wavelength. Also, I mean, it is possible that one can measure what is the value of this region. This region means the refractive index of this region. Suppose I have this experiment by putting some kind of oil here, instead of air, if I put some kind of oil here, whose refractive index, say it is N oil, then this refractive index of the oil can also be measured, also be calculated using this experiment. So, today I do not have that much of time, and also like to in the next class maybe I will do more calculation to show that how these rings are formed and how the width of the ring is changed with the order of these Newton's rings. If I increase the order, how the width will go to change, and also like to show the technique through which if a unknown liquid or any unknown substance is placed here in between this wedge like structure, then how somebody can calculate the refractive index of this, exploiting this Newton's ring, very interesting Newton's ring system. So, with that note, I would like to conclude. So, today what we learned is how one can find out the unknown wavelength lambda by exploiting the Newton's ring experiment, and all the mathematics for Newton's ring experiment, where by knowing the value of r, one can calculate. R means the radius of curvature of this these convex glass substrates. So, one can find out the radius of this ring as well. So, with this note I like to conclude. So, in the next class I will do more on the Newton's ring, where we will show that how unknown the refractive index of the unknown while can be measured with the same technique. So, hope you will going to enjoy that treatment as well. Thank you very much for your attention and see you in the next class.